What if I told you that the Atlantic Ocean is getting wider right now? Not because there's more water entering it, but because the continents on opposite sides are slowly moving apart. North America is moving away from Europe. South America is moving away from Africa. And hidden beneath thousands of meters of water is an enormous geological structure responsible for much of this movement, the Mid-Atlantic Ridge. Every year, parts of the Atlantic widen by a few centimeters. That sounds tiny. But give Earth millions of years, and those centimeters can create an entire ocean. To understand what's happening, we have to travel beneath the Atlantic. Running roughly down the middle of the ocean is a gigantic underwater mountain system called the Mid-Atlantic Ridge. It stretches for thousands of kilometers from the far North Atlantic toward the Southern Ocean, and it is part of the longest mountain range system on Earth. But unlike the Himalayas or the Alps, most of it is hidden underwater. The ridge exists along a divergent plate boundary. This means enormous tectonic plates on opposite sides are moving away from one another. In the North Atlantic, the North American plate is separating from the Eurasian plate. Farther south, the South American plate is separating from the African plate. As these plates pull apart, hot material from Earth's mantle rises beneath the gap. Magma can reach the seafloor. It cools, hardens, and becomes new oceanic crust. Then the plates continue moving. More material rises. More crust forms. And the process repeats again and again and again. This is called seafloor spreading, and it means parts of the Atlantic seafloor are continuously being created. But here's where the story becomes even more incredible. The Atlantic Ocean didn't always exist. Around 200 million years ago, Earth's continents were joined together in the supercontinent Pangaea. North America was connected to parts of Europe and Africa. South America was connected to Africa. There was no Atlantic Ocean separating them like there is today. Then Earth's crust began stretching and breaking apart. Huge rifts formed. Pangaea started splitting. Magma rose between the separating landmasses. New oceanic crust formed, and slowly an ocean was born. First, the early Atlantic was relatively narrow, but seafloor spreading continued for millions of years. The Americas moved farther west relative to Europe and Africa. The Atlantic became wider, and the coastline shapes we recognize today slowly emerged. In fact, look at South America and Africa on a map. Their coastlines appear as though they could almost fit together. That's because they were once connected as part of the same, larger land mass. But the strongest evidence isn't simply the shape of the continents. Scientists have found matching geological structures and fossils on opposite sides of the Atlantic, and the ocean floor itself records the history of its expansion near the Mid-Atlantic Ridge. The oceanic crust is relatively young. Move farther away from the ridge, and the crust becomes progressively older. It's almost like Earth's seafloor contains a geological recording of the ocean growing. And we can actually see this process above water in one extraordinary place, Iceland. Iceland sits directly on the Mid-Atlantic Ridge. There, the North American and Eurasian tectonic plates are pulling apart. The island is also shaped by intense volcanic activity linked to its unusual geological setting. In places, you can literally stand in landscapes created by the forces separating these plates. But does this mean the Atlantic will simply keep growing forever? Not necessarily. This is where Earth's future becomes difficult to predict. Oceans aren't permanent. They are born. They expand. And eventually, some can begin closing. The Pacific Ocean, for example, is surrounded by many subduction zones where old oceanic crust sinks back into Earth's mantle. The Atlantic has far fewer major subduction boundaries around its margins today. That's one reason its basin has been expanding. But over tens or hundreds of millions of years, plate boundaries can change. New subduction zones could develop. Continents could change direction. And one day, the Atlantic's expansion could slow or even reverse. Some models of Earth's distant future suggest the Atlantic could eventually close as the continents assemble into another supercontinent. Other models predict a very different future. Nobody can know exactly what Earth's map will look like hundreds of millions of years from now. But right now, the Atlantic is still being reshaped by seafloor spreading, and the evidence is hidden beneath the waves, an enormous mountain range. Fresh volcanic rock, moving tectonic plates, and a seafloor that becomes older as you travel away from its center. We think of oceans as permanent features of Earth, but they're not. Around 200 million years ago, the Atlantic as we know it didn't exist. Today, it separates entire continents, and millions of years from now, it could be wider still. So when you look across the Atlantic Ocean, you're not looking at a finished landscape. You're looking at a planet in motion, slowly, silently, a few centimeters every year. Earth is still pulling the Atlantic apart.